Okay, here's an example of synthetic division. I have a polynomial here. P of x is 2x to the fourth plus x cubed minus 17x squared plus 1, and I'm dividing it by x minus 2. And I get some quotient plus remainder over the divisor. And synthetic division is quite simple. I write this from x minus 2. I'm going to write 2 here. And I write the coefficients of the numerator here. So I have 2, 1, negative 17, 0, 1. This 0 here is because there's no x term. Negative 17x squared plus 0x plus 1. So if I'm missing terms, I have to fill this out. Now the algorithm itself is quite simple. This 2 comes down. 2 times 2 is 4. I add to get 5. 2 times 5 is 10. I add to get negative 7. 2 times 7 is negative 14. And I add to get negative 14. And 2 times that is negative 28. And I add to get negative 27. And it turns out this right here is r, it's the remainder. And right in here, these are the coefficients of q. So my RQ of x is, well, here's a constant x squared, x cubed. So I have 2x cubed plus 5x squared minus 7x minus 14. And as I said, r is negative 27. What we can also do is, we might know, I claim that that r here is p of 2. Okay, and that's actually fairly straightforward, because if I have p of x over x minus 2 is q of x plus r over x minus 2, and I multiply through by x minus 2, I get p of x is q of x times x minus 2 plus r. So p of 2 is q of 2 times 0 plus r. But q times 0 is 0 plus r is r. So I get r equals p of 2, which you can verify directly. Now it's a little bit different if you have x plus a constant in the denominator. So let's do an example like that. Let's say I have something maybe quite simple. X cubed plus 2x squared minus x plus 5. And down here I have a x plus 3. Then what I'm going to do, I'm going to have negative 3 here. I have a 1, 2, negative 1, 5. So the 1 comes down, I have 1. Negative 3, negative 1, 3, 2, negative 6, negative 1. So I have all this going on. Again, the algorithm is quite simple. And you can show this algorithm is true by using long division of polynomials, which we won't go into today. But anyhow, this is r, and this is my q of x. So my q of x is what? Constant x squared. So I have x squared minus x plus 2, and my r is negative 1. And so when I claim that negative 1 here, so I get, if I put 3 into this numerator here, just likewise. And that's that.